Hello, everybody. Good afternoon. Welcome once again to one of our regular X Spaces. Johnny, let's test your mic, see if you're all set up there.
Hey, can you hear me okay?
Absolutely. It's all going well.
Cool.
Fantastic. Thanks for joining us today. We've got a quite an interesting topic, I think, today, especially due to some recent posts and articles and following commentary in media and things like that. But we'll start off with you. Everybody, give Donny a warm welcome, one of our engineers at Gensyn. This is actually his first Twitter space, to the point he had to even sign up to X to get an account. How are you feeling about the whole thing?
Pretty nervous, but I'm here.
All good. It's nice and easy. Why don't you give a bit of an introduction of yourself and where you fit in at Gensyn? We'll start there.
Sure. Yeah, my name's Johnny, and yeah, I'm an ML research engineer at Gensyn. So yeah, that means I'm not too good at research and I'm not too good at engineering, but I just sit in the middle somewhere. And I've been working at Gensyn since March of last year, so just about a year now. I was for that time. I've been the tech lead on RL Swarm since June, so kind of saw that through from when we introduced the GenRL framework, and then built out the reasoning gym and the Code Zero RL environments on top of that. Yes, I guess I've been working in ML since about 2017. Yeah, I did my master's in computer science and started doing ML stuff at NYU, and then did a PhD in computational physics using machine learning to try to improve the efficiency of plasma physics simulations at the University of New Hampshire. And then since then I've been working in industry. So
Fantastic. When you were kicking off that computer science qualification, was machine learning and AI in your mind as your future, or was that a turn that occurred somewhere along the way?
no, that's why I specifically signed up. I was pretty excited about um, yeah, machine learning. I didn't really know about any of it, to be honest. Before that, I was not in tech or anything. I was just kind of just saw an article that said talked about how machine learning was being used to optimize propeller um, engineering, and I thought that's pretty cool that machine learning can do stuff that humans hadn't done. So I just kind of just rolled the dice and just started that program out.
Fantastic. So dedicated to it right from the start. The
Yep.
So the reason we spun up this topic this week generated a bit of an internal conversation. When was it? Last week, I think, when a couple of large blog posts, following media articles came out around distillation, particularly from Anthropic and some other competing companies. Why don't you take us into what is actually distillation?
Cool. Yeah. So let's see. So I guess distillation's been around for over 10 years now. I think, as far as I know, the first time it kind of appeared in literature was in 2015. Geoffrey Hinton, who everyone probably knows at this point, he won the Turing Award in 2018, and then he actually also went on to earn the Nobel Prize in physics. So him and his collaborators put out a paper, which was sort of the seminal paper on distillation. And what they described is kind of still how it works today, more or less. It's sort of the situation where, very similar to humans, you set up the situation where you have a teacher AI model
Mm-hmm.
and then a student AI model, and the goal is to distill or take the knowledge and experience that's been trained into the teacher model and transfer that into the student model.
Mm-hmm.
And there's like a lot of reasons people would want to do something like this. But like generally the way it's done is the teacher model tends to be something that's like huge, like a 400, 500 billion parameter language model. And then the student model is something that's way smaller, like 30 billion, 8 billion, something like that. And so the company will spend a lot of money training the teacher model. And then it becomes like the tokenomics aren't very like favorable to serve the teacher model to all of their users. Or like maybe you're just like physically limited by the hardware and you like can't get the teacher model where you want to go. Like if it's an edge device, maybe you're running it in a smart camera or on your cell phone or something. And so you have to try to get as much of that information as you can into a smaller model that can get the job done. And yeah, I guess yeah, like just to paint like a little bit more of a picture, like the way it works is it's honestly super similar to the way people are taught. So like in school, you have a teacher and a student, and you kind of like go in with this like base assumption that there's some sort of similarity between the teacher and the student. So like in most cases, like if the teacher speaks English, the student will also speak English. If like if the student spoke French or something like that, you'd have a really hard time getting the information from the teacher into the student. So like you assume that there's some sort of similarity, and the way it works is maybe I should back up a little bit, I guess, and just say like the standard. So like the standard training pipeline for these LLMs is kind of like a threefold pipeline. They start off with like a large pre-training run, when that's like where you hear this like term like all the information on the internet or like internet size data.
Right.
And so they pre-train the language model and they sort of just like bake in all of this like latent information, and it's kind of hard to access, but it's all in there. Then they'll do something called supervised fine tuning, where they take like a very small data set, something that's much smaller, but like it exhibits like the properties that they want their model to exhibit. And they'll do next token prediction, but like in a supervised manner using this like very small data set.
Mm-hmm.
And then finally, they'll do reinforcement learning post training. And the post training is when you don't like introduce any new skills really, but like you bring to the front of the model the skills that you want. And so the way distillation is done is you go through all three of those steps with a teacher model, and you bring it like fully to production quality, doing exactly what you want to do, but it's huge and it's like unwieldy.
Mm-hmm.
And you don't go through all the steps of the student model, but you'll bring the student model through the pre-training, and then oftentimes they'll bring them right through the supervised fine-tuning as well. But then rather than going on to the reinforcement learning, which is it can be like pretty costly and it takes a long time to get convergence with RL. So instead of doing that, you'll do something like distillation. And what you do is you'll generate synthetic data, it's called. And so you take a bunch of prompts and you prompt the teacher model and you generate a whole bunch of responses. And so you have this data set that consists of prompts and responses from the teacher model.
Right.
And you pass them through the student model. And the student model is going to generate its own responses to those prompts. And from there, you compare the responses. You compare the student's responses to the teacher's responses. And if the student is responding in a way that does not closely emulate the way the teacher would respond, then you're going to penalize the student and perform a weight update so that it learns and it can more closely emulate the teacher model. And so you go through this like basically as much as you can until as much knowledge from the teacher has been distilled into the student as possible.
Mm-hmm.
And so like what I'm describing is exactly the framework that Geoffrey Hinton laid out in 2015. And oftentimes it's called off-policy distillation. Like that's just a bit of jargon, but they call it that because the data originally comes from the teacher. Yeah. So yeah, I guess if I can kind of just like kind of go through like the two other like main like improvements in the field the way I see it. I think it'll kind of be like helpful to paint the full picture.
Sure. So in effect, the distillation of the knowledge from the teacher model to the next model, the student model, is a lot of its purpose is around the size of the model and how unwieldy it is, how you could use it in, how you can't use it at that size in many contexts, and then you were talking about the cost being passed on to users of the model. Would that be a bit of a summary there?
Yeah, exactly. Like we've all seen it, like with our either our like agents, or if you're using like an IDE that has a built-in, you get to pick which model you want to use and how many tokens each model costs per prompt or whatever. The larger models always cost like 3x or 5x the number of tokens of the small model. And so like it's more like economical for us to use a student model, and it's more economical for the companies to serve a student model.
Right. So why is that process, which seems to be creating efficiencies, creating benefits for users, why is that sometimes seen as controversial or not the way to go?
I think there's like kind of a few reasons. Let's see. I think like maybe it would be helpful to kind of like, if you don't mind, I feel like I'd like to just kind of talk through like two small improvements to like distillation from the way I originally described it, and then I think like it'll make a lot of sense.
Please do.
So like that first, what I just described to you was called like off policy distillation, and that was sort of like the best in the business for like almost 10 years. And then in 2024, this like on policy distillation, or they call it general knowledge distillation procedure, came out. And like the big change there is that when you generate your synthetic data, rather than getting the synthetic data from the teacher and training the student on it, you generate the data right up from the beginning from the student, and then you go over to the teacher and you check and you say, the student generated this response, does it look correct? And if it looks correct, then nothing happens. But if it looks incorrect, that's when you perform the weight update, so it try to matches the teacher. So it's almost just the polar opposite of off policy distillation. But there was like a big improvement there that's like sort of subtle. And so like the kind of like the canonical example is, if you were like learning how to drive a car and the teacher was instructing you on how to drive a car and you learned and you got your license, you'd be great. But the whole time that the teacher was instructing you, you never crashed into a tree. And so you wouldn't know what to do if you did crash into the tree. So now you're out in the real world driving around and you crash into a tree and you don't know if you're supposed to slam on the brakes, swerve the car, or like how to get your car out of the ditch or whatever it may be. So you're just completely unprepared for that situation. And so that's what happens with the off-policy distillation, because you're just trying to mimic the large model. You don't really like learn how to like think for yourself. And when you kind of get off track, you don't know how to recover. But with on policy, since the small model is generating those responses right from the beginning, it can sort of like correct course and make better decisions as the token generation progresses.
Mm-hmm.
And so like this is like the gold standard for like performance, but there's still like one big thing that this doesn't resolve, and that's that you need to have this tight similarity between the teacher and the student models. So the similarity needs to be architectural. They need to be like the same family of models. So you would distill a large Gemini into a small Gemini and a large Claude into a small Claude, but you wouldn't distill like a Quen model from a Gemini model.
Right.
And that's because it requires that they use the same tokenizer. And so like the last big thing that I just want to like touch on is called universal logic distillation, which was like a fast follow to general. These are like so much jargon to like the on policy distillation. And that like lifts the requirement that the tokenizers are the same. And so like with that final like improvement, you can now distill a large Gemini model into a Quen model, for example. And so you can benefit from like these cross families of models. You can benefit and do your own distillation without knowing what tokenizer they used. And so like just for example, and not at all related to recent events, We don't really know, like Claude's tokenizer is proprietary, but for example, Quen's tokenizer is not proprietary. And so this would enable you to distill Claude into a Quen model.
Right. Okay.
Sorry. So yeah, so your question was, Xavier, like when would you want to use this in the real world, right?
Yeah. So this one use it in the real world, and then I was saying that most of the things
I think so.
most of the things we've
So like companies will, so like the way that this was like intended to be used, the way companies will use it all the time is they will either just train a very large teacher model and then distill it into a small student model and serve that to you as the customer when you know what it is that you're paying for. And that's good. Like you have this tacit agreement that you're going to pay fewer tokens for a smaller model. And it seems like there's this trade-off there, this trade-off between model size and expense with how much performance the model is going to give you. But like the super interesting mystery about distillation that actually no one can really explain is like this dark knowledge like transfer. And so a lot of times you'll see that under certain circumstances, when you distill the teacher into the student actually will perform better than the teacher did, and it will be a smaller model.
Oh, that's interesting.
So it's honestly like magic. Like no one understands how it works, I think, and it's like kind of like a mystery of AI and machine learning that like you can just trim away all the fat and then like outperform the big model itself. So I guess that's like a PSA that you don't actually need to spend all your money on the bigger models all the time, because a lot of times the smaller model will do even better. But the other way that companies will use this is with this thing called speculative decoding. And speculative decoding is sort of like a shady business practice from like the user perspective, but it's kind of like required from an infrastructure perspective.
Mm-hmm.
And the way that works is when you as a user prompt an LLM, they send your prompt, and you think you're prompting the large model. What they'll do is they'll send your prompt to the small model, and they'll generate tokens with the small model, and then they'll check them against the big model. And for as long as the small model is producing the tokens that agree with the big model, you'll get those tokens. But the minute that the small model begins to deviate from what the big model thinks is the correct answer, then they'll adjust, and they'll either reprompt the small model, or they'll serve you the tokens from the big model from that point forwards. But I say it's like a little bit shady from a user perspective, because you think you economically you're paying this company to use their large model, but what you're getting is the product of the small model that you could have paid a less amount for and gotten the same product. So I guess like those are sort of like the two ways that companies are like really using distillation with these like in like terms of like this LLMs.
Okay. So what was the reason for the recent posts that we were talking about last week? Can I check you can still hear me? Can you hear me?
I'm not sure if you're there still, Xavier. I can't quite hear you. Well, can anyone else hear Xavier?
If anybody can hear me speaking, just throw up an emoji there. It's coming up. One moment, everybody. Sorry about this. Terribly sorry.
Okay. I don't hear Xavier, but Ozzy said he can hear me.
Hello, how's that? Is that better?
Hmm.
Can you hear me now? Can you hear me now, Johnny? No. Give me a moment.
Okay, I guess I don't know. I can't hear Xavier, so I'm just gonna talk about things I want to talk about, I guess. Um,
Johnny, can you hear me now? Johnny, can you hear me?
okay, yeah. So I guess I can just sort of like bring this full circle then, to tell you a little bit about how RL Swarm was. So we ran RL Swarm for about 9 months, and RL Swarm was basically, you could think of it as like this massively decentralized distillation engine. Um, oh, yeah, just talk. So yeah, I think like probably everyone in this room knows that RL Swarm was what it was, but I can just sort of like refresh that. Um, so it was like this fully decentralized reinforcement learning environment, and it was decentralized because anyone, it was open and permissionless. Anyone could join it. It didn't have any central entity controlling it. And what it is, you would join the environment, you'd bring your own locally hosted model, and then your model would generate outputs to a prompt, and it would send those outputs into the swarm so that everyone else could then use them. So like what I'm describing is super similar to the 2015 off policy distillation I talked about earlier. Um, yeah, so like you can sort of imagine yourself as being a teacher model, and then someone else in the some anonymous node in the swarm as being the student model. You're going to generate a response to a prompt and send that out there. They're going to receive your response and your prompt, and then they're going to update their weights, pretending as if they had generated that response themselves. And so there's like this benefit here that they are saving dramatically on inference compute because you're doing all the work and they don't have to do it. Um, but but also it's like bidirectional because it's fully decentralized. So you're getting the same benefit from others. After you send your response into the swarm, you retrieve all the responses from the swarm and you pick a couple, and then you update your weights based on theirs. And so, yeah, so like this is exactly the off policy distillation that I talked about, and it like with the slight caveat that it's like absolutely completely chaotic, and you're not distilling from a larger model into a smaller model. You're just distilling from some unknown model. Like their responses could have come from a big 400 billion parameter model. It could have come from a half a 0.5b parameter model. It could have come from some human who was just sitting at the keyboard and typing nonsense in. Um, so it was like completely chaotic. But I feel like that was actually like kind of one of the exciting things about it, because you don't really know like how the models will perform from learning in this like very vibrant society of models. Like this sort of like takes distillation like one step further from like student and teacher almost to you're like now unleashing your model into a full society and just learning from everyone else that's like interacting with you around the society, just like we would in the real world. And so your model has to sort of figure out like what responses are correct and what responses what it wants to learn from and what it doesn't want to learn from. Um, um, yeah, and so that was like it was like a really interesting experiment to run, and what we ended up seeing was that in some cases like we could sort of like because when you were running nodes, you were uploading your models to Hugging Face. So we could look at those models and grade them, and we could see that in some cases the models were performing much better than if they had just trained by themselves in isolation without joining the swarm. But in other cases, like, it wasn't true at all. The models were doing very bad. So like some of them were adapting to the society and some of them weren't. And it's sort of like hard to like pin down when it was beneficial versus when it wasn't beneficial. But it was pretty interesting. And I think that like for the like the next iteration of this, like the one thing we would want to like refine probably is how the models are selecting the responses that they want to distill on. So like rather than just being like completely chaotic, we would try to like use some sort of filter function that like the user could assign to to decide on what morals or like ethics they want their local model to learn from the swarm. So yeah, so the way we did it was we did it with this like 2015 formulation of distillation. And recently in the news, what we saw was that these three other companies used the more modern form of distillation. It was a DeepSeek, Minimax, and Moonshot. They used the universal logic distillation that I had like touched on. And so if you remember, that was the one that lifts the requirement that the models be in the same family and they can have different tokenizers. And so these three companies made over like, I forget, like 24,000 or something accounts, and they were just hitting Anthropic's API. And so they would prompt the API and they would get the response. And they did it with all these accounts, and they generated some sort of like massive synthetic data set from Claude. And then they were able to take a small model that was architecturally different from Claude and use this more modern distillation technique in like a very targeted way, which was like completely the opposite of RL Swarm. Like, we were chaotic and we just wanted to see how models would evolve in a society, whereas they wanted one specific model to learn one specific like set of like one specific like constitution or like set of principles. And so they generated these massive data sets from Claude and they taught their models on them. And so they distilled the large Claude model into their models. And then they came back to the public benchmarks and said, look, our models are doing better than Claude, or better than these other open source models at the very least. And so like they sort of like set this, like they sort of like jumped to the top of the leaderboard and said, we have like the best open source models on the planet. And so Anthropic was like very upset because from their perspective, these companies had just stolen all of their hard earned data and bypassed their safety mechanisms that they had baked into Claude. So like Claude has a lot of restrictions on it, on what it can and what it cannot respond with. But they took all of the knowledge that was in Claude and they put it in a separate model without those restrictions. So they effectively just sidestepped like Anthropic's like safety constitution and gave us Claude in a different package. And so that's why they were like very upset. But I think it's like pretty controversial as to whether or not Anthropic deserves to be upset by that. A lot of people say that Anthropic stole all their training data from other people. And so fair is fair. Yeah, so I think it's kind of a matter of perspective, but regardless, it's kind of interesting to see this distillation technique like used in the wild, and Anthropic admitted that it was used on them, and to see like how successful it worked. And yeah, so like the outcome from my perspective is that it's great that it worked, and it gave us these open source models that have top tier class leading intelligence. And yeah, so like that's like great for like our mission of decentralization, because now anyone can access these models, anyone can load them up locally, and anyone can get the benefit of this like closed ecosystem that Anthropic was proposing.
Fantastic. Johnny's still having some listening issues, but what a really nuanced kind of argument, a nuanced kind of topic with opinions on both sides around technology and how it changes. Always seems to be the case that various stakeholders will have very, very different views. But thank you so much, Johnny, for taking the time out of your day to come and speak to us around distillation. And I think you can hear me now, so you can jump in whenever you like, Johnny. Thank you so much for that. I found that quite fascinating myself. Anybody out there that wants to ask any further questions or get a bit more detail, jump into the Discord and we can continue chatting away there.